Okay, today we're going to be looking at, so we talked last week about some of the applications of using the sum difference formulas, using them to find other values that are not on the unit circle. Things like 15 degrees, things like 75 degrees, things like 105 degrees, and more. Today we're going to showcase kind of the other application, which is how we use this to modify graphs. Now, you guys, when we were doing the graphing section, we all agreed the phase shift questions sucked. Well, the nice thing is, these formulas don't just work with alphas and betas, individual values. They work with variables too. And so we can actually apply these and change a function from being in terms of, sine with a phase shift to being in terms of another function entirely. Here we go. Now, to do this, all I have to do is think about these formulas not in terms of alphas and betas, but in terms of x, y, and a number. Here we go. Now, if I wish to graph this equation, I'd have to do a phase shift problem. However, for many applications in trigonometry, phase shift is not just annoying to graph by hand, it's annoying to use. A lot of basic applications of these functions do not work well with phase shift. So, we're going to use the formulas on the board up here to modify this function to be in a different form. We're going to use the difference formula in this case to rewrite this function in terms of two trig functions rather than one trig function. Now, that might look a little annoying at first or a little different, but for many applications, it is significantly improved in terms of the actual usefulness of it and the ease of use of it. So, here we go. To do this, and we will check our results at the end of the problem, we will show that this graph and the one we're going to get are the exact same graph. Here we go. To do this, I have to declare, just like last week, an alpha and a beta. So my alpha in this case is going to be my x value. My beta, pi over 4. What I will do is take these functions and plug them into my difference formula for sine. What it will do is it will transfer from one sine function into two different functions, each of which is simpler. Here we go. To do so, I use the second formula. Sine of alpha minus beta is equal to sine of alpha cosine beta minus cosine alpha sine beta. So this function becomes sine alpha, so sine of x, times cosine beta, so cosine of pi over 4, minus cosine of alpha, so cosine of x, times sine of beta, so sine of pi over 4. Just like with last week, the unit circle comes in clutch. We use the unit circle to determine things like sine of pi over 4 and cosine of pi over 4. This will give me a new way to write this function. Here we go. The first piece, sine of x, is just sine of x. Cosine of pi over 4 from the unit circle, square root 2 over 2. Minus cosine of x is just cosine of x. Times sine of pi over 4. Sine of pi over 4 is square root 2 over 2, again, from the unit circle. I then make this algebraically appropriate by taking the constants and moving them out front as coefficients. That means my solution is, the way to algebraically rewrite this function is square root 2 over 2 sine of x minus square root 2 over 2 cosine of x. Notice that the phase shift has disappeared. It is gone. There is no need for it anymore. The sum difference formula allows us to negate the phase shift by splitting this from one function into two. Now, whether that's easy or hard is kind of up to the individual or the program you're running. Like I said, a lot of applications of this use a lot of computer programs. And for some computer programs, believe it or not, two easy programs run faster than one hard program. It just makes sense. What we're going to do now is I'm going to actually plug these two into decimals. I'm going to plug the original equation, sine of x minus pi over 4. I'm going to plug it into decimals to see what it looks like. It's going to look like the sine function phase shifted to the right pi over 4. Now we'll calculate the function. And in theory, it should look the exact same, just with two functions, sine, cosine, being subtracted instead. They should look the same. Because we used a formula that we know should work. So let's see if they match. Desmos. The first function, again, is smaller but more complex in terms of using the math itself. X minus pi over 4. So I can see this function, if I look very closely, it's the sine function, just shifted to the right, pi over 4. So my starting place is at pi over 4, it then goes up, descends back down, and 1 period later ends. It's the sine function, shifted to the right, pi over 4. Let's look at the other version of this function. Again, more complex in terms of the individual parts, but no phase shift, so in theory, nicer for many applications. My first piece is square root 2 over 2 sine of x minus square root 2 over 2 cosine of x. And take a look. These two functions, despite looking radically different, have the same intrinsic value, which is pretty deep in and of itself. We have two functions, one with a phase shift, one without a phase shift, yet they have the same results. Show me your problems in your homework tonight. Ask specifically to convert from one function into two, removing the phase shift specifically. This is what it's asking you to do. It's asking you to apply either a sum or a difference rule in order to find your new equation in its new form. Another one. This is a sine function. Let's look at a cosine one. Same process, similar pieces. Let's see what they look like. My second one. Let's do cosine of pi over 2 minus x. Now, the previous one did not simplify a lot. The unit circle gave me two values, square root 2 over 2 and square root 2 over 2. Not much to simplify. Some of them simplify a lot more. Take a look at this problem. We're going to rewrite this function in terms of two functions, sine and cosine. So, look at the previous one. I'm going to go to my correct formula, which in this case I have a subtraction problem, making the pi over 2 my alpha, the x my beta. I take these two, and I plug it into my difference formula for cosine. Now, this one, because of the values I have chosen, simplifies this much more. Here we go. So, my function should be, okay, I go to the cosine one. Cosine, I have subtraction, so I use this formula. It says cosine alpha, cosine beta, plus sine alpha, sine beta. So I go over here. Cosine, pi over 2, times cosine, x, plus sine, pi over 2, times sine, x. The reason this simplifies nicer is because of pi over 2. Pi over 2 has some neat properties when it comes to trig functions. Let's plug them in. Cosine of pi over 2 is 0. Plus sine of pi over 2? 1. Now I use algebra. The 0 times cosine, well, anything times 0 should make it go away. So this becomes just 0. 1 times sine, well, that's just sine. So it turns out that this original equation is just the sine equation. Look at that. And to a computer, one of those is significantly faster and easier to use. So knowing that property or being able to convert between these two is very nice. And to prove it, I will, again, pull up Desmos and graph these two functions. In theory, This one is weird because of where the x is. So let's talk about what's going to happen in this thing. First, the negative is going to swap left to right, the values. And the pi over 2 is going to shift this to the left pi over 2, positive pi over 2. So what happens? I take my function. Let's grab it. The original equation is cosine of pi over 2 minus x. Cosine pi over 2 minus x. Oh my. From the picture, it's much easier to convince yourself that this is a sine function. I mean, look at that thing. That's a beautiful sine function. Let's verify. Functions. Sine of x. Yep. What's that? Yet one might be derived from a calculation or from a formula, and the other can be brought about from the formula we're using, making it nicer. Much easier to work with. If I asked you to graph the other one, most of you guys probably look at me with blank faces and you're like, no, please don't. I don't want to. Please. Please. Sign, you can't sign 100. So, we'll do one more with tangent. The tangent is once again the weird one because the formula for tangent is the weird one. Can't get around that. Let's do a tangent one real quick.
These are the longer ones.
Usually, I'll try to pick a nice value. Let's see. No, I can't pick a nice value. What? Tangent of x plus pi over 3. Now, unlike the ones last week, I'm not going to worry too much about simplifying this. My goal is just to get a new function. All right, here we go. We're going to take this function, we're going to rewrite it in terms of a new function that has 2 versions of tangent rather than 1 version of tangent. Again, I am eliminating the phase shift. So if I think about what this function looks like, again, I have x plus pi over 3. As a reminder from our phase shift section, this tells me this is going to shift this left by pi over 3. Meaning the center will not be at 0, it'll be moved to the left, pi over 3. The left boundary will not be at negative pi over 2, it will be at negative pi over 2 and pi over 3. Like everything will shift.
I'm confused. So even if you change it to look different, it's still going to have a phase shift. It's the same graph.
It'll have the same graph, but there won't be a phase shift specifically in those pieces.
So like if you want to graph like the last one, like sine of x,
Huh?
I was kind of confused.
The phase shift went away, right? Before there was a pi over 2 inside the function, so there's a phase shift.
Yeah.
And then now it's gone because it's just sine of x. In theory, we eliminate the phase shift. Now, is that going to cause other parts to get possibly more complicated? Yeah, look at the first one. The first one now has a number out front, which would affect things like the amplitude. And it's to be added or subtracted together. So it's not making it easier, it's changing the look. Because for us, it may not be easier, but for a computer it is.
So we don't actually have to graph this.
No, we're not required to graph any of these. What I do ask you to do is verify your results using a graphing method. Make sure you are right. Don't just type down the answers and hope they're good. Verify them. I don't want a single question wrong. Because you all look at them and be like, I tried it, it didn't match, something must have gone wrong with me after the class. Alright, let's do this. So again, I take this, I'm going to rewrite it in terms of 2 different functions rather than 1, but in doing so the phase shift will go away to replace with something else. So I use the top version of tangent, which has the plus sign for it's a sum problem. So it says tangent of alpha plus tangent of beta over 1 minus tangent alpha tangent beta. Let's do it. Now again, my alpha is x, my beta, pi over 3. Let's do it. Tangent alpha, so tangent x, plus tangent beta, so tangent of pi over 3, all over 1 minus tangent alpha, the tangent of x, times tangent beta, tangent pi over 3. And like I said, I'm not going to simplify a lot for these because that's not the goal. The goal is to rewrite them. So I'm going to get to the next step, which is plugging in the unit circle, and I'm going to stop. Here we go. My solution should be equal to, on top, tangent of x is tangent of x. We have not gotten rid of the tangent function. We have rewritten it so it no longer has the pi over 3 inside of it. Plus, what is tangent of pi over 3?
Square root of 5. 3.
Square root of 3. On bottom, 1 minus tangent of x times the square root of 3. The only thing I will do more is put the tangent in the square root of 3 in the right order. So this becomes tangent of x plus the square root of 3 all over 1 minus square root of 3 tangent of x. Correct algebraic order. And that's where I will stop. Again, I would be very hard to argue here that this is better than the previous one, but the phase shift is gone. That was the goal for the long term. And for a computer, I cannot stress enough. I hope some of you may go into a field that uses this stuff. I really do. Because there are some cool applications of this. This process, this version, looks harder to us as humans. It takes fractions of a second faster than the other one. And that matters to some applications. If you're doing a billion of these problems for an astrophysics application, you're going to want to save a fraction of a second every time. It matters. So, again, this is an alternate way to rewrite it. Now, it works both ways. Meaning, you can take it and apply it to get us into this expanded form, let's call it, where I go from one function into multiple functions, but it can also work backwards. Let's look at some of those.
That an 8 to 6 or an 8?
6.
I could tell.
How's that look like an 8?
Oh, you could jack it up.
Alright.
You never know what that was.
True. This is the expanded form. Let's contract this down to one trig function.
It seems like it's not going to be this fun.
Well, the trick is figuring out which of these it could be. And then figuring out the alpha and beta and plugging them in. So, first, which trig function is this? I got 6 options up here. Remember, there's a sum version and a different version of each one. So which one is it?
Sine.
Cosine.
This is the sine one. But which one? There's 2. There's a sum, the top one with a plus in between.
The black one.
Yeah.
And it's top. So this is somehow going to be equal to sine of alpha plus beta. So all I have to figure out is, okay, well, what's alpha and what's beta? So in this problem, what's my alpha? X. What's my beta?
5 or 6.
5 or 6. So it's just being able to go the other way. Now, the only place where this can get worse is, of course, what if I didn't have cosine of 5 or 6? What if I already went to the unit circle and found the value instead? Let's do one more. These ones are the harder ones because you have to be paying attention to the values and remembering the forms. Here we go. This time, 1/2 cosine of x minus square root 3/2 sine of x. We are going to convert this back. before I can do so, I have to figure out which one could this be.
Sine.
It could be sine.
Tangent.
It could be the bottom version of sine with the subtraction between them, right? I would doubt it's tangent because tangent, both versions of tangents have tangent in them. As it turned out, it can also be cosine.
I think it most likely be cosine.
So we have two different versions of our solution now.
The sum of cosine.
We could do the sum of cosine or the difference of sine, the subtraction of sine. Well, these problems you gotta make a call. And so, here you go Garrett's, where we do the cosine. Here you go Levi's, where we do the sine.
I haven't been here in the last like 3 days. So.
Let's do the cosine.
Okay. I want you to try this. Because in a second I'm going to ask you what it is. Alright? Okay, so if we're going to do the cosine, remember, the cosine's regular formula. Right? Cosine, you said the top cosine, right? That's alpha plus beta is equal to cosine alpha, cosine beta, minus sine alpha, sine beta. So it's obvious from this point what beta is, I hope. Beta is x. What's less obvious is what's alpha. So it should be, again, I hope it's obvious to everybody. And if it's not, say so. I will not be sad. I will be happy that you stood up and said, no, it's not easy, Douglas. Please don't do this again. I hope it's obvious that x is my beta. Just look at it. Okay? So now I want to go to the unit circle and look for two things. Where is my cosine value 1/2? Where is my sine value square root 3 over 2? 5 pi over 3 is one of those places. Pi over 3 is another. In this case, my alpha.
It doesn't matter, does it?
It turns out in this case, no. Now, where we get some complications is at 5 pi over 3, I think one of the values works, but I think the other one may not.
Okay.
Oh, I know what you're saying. I know what you're thinking. At 5 pi over 3, you get this.
Yeah.
But that would mean that the negative is put into here, meaning that this would become a subtraction sign. So, like, there's a lot of nuance into this. Be very careful. Check your answers with the original problem and see, do they still match? So, let's try these two out. So we said our solution, we think, is cosine of pi over 3 plus x. And we're going to check that. Now, there are other versions. If we had done what Cole mentioned, we get a slightly different version where it would be 5 pi over 3 minus x. It's a slight variation, a slight difference. Levi, did you try it your way and see what you got?
Wait, question.
Yes, sir.
So this has cosine minus sine. And everything up there has a parity in some way.
Because there's more than one way to write them. Example, if you do it Levi's way, I believe Levi, that's the solution you get. You should get sine of pi over 6 minus x. I think that's what you get, Levi. Double check it, please.
I had it the other way.
You got it the other way? Then we'll check both, okay? Okay.
Wait. Sorry. Go ahead.
Okay. Alright, let's do it. So I'm going to graph the original equation, which was 1/2 cosine of x minus the square root of 3 over 2 sine of x. I'm going to graph that equation. I'm going to graph the answer that we got trying it Garrett's way, and then I'm going to graph it the other way using what Levi said. And hopefully, all three of these should match. Just different variations using the sum difference formulas. All right, let's get it on there. Let's see what happens. There's most. Let's see. 1/2. 1/2 cosine of x minus square root of 3 over 2 that was sine of x So there's my equation. Ooh, pretty. Here we go. Let's see. The version we got was cosine of pi over 3 plus x. Hey, look at that. Perfect. All right, Levi. There were two variations. There was my variation and your variation. I think mine was right. I think you made a simple mistake putting him in the wrong spot. I think you chose the wrong alpha. This is why you check. So your version was sine of x minus pi over 6.
Oh
snap.
dang.
But let's try it the other way. So that was just you chose the wrong alpha. Or you might have chosen the wrong beta. You might have just got them out of order. You might have chosen beta and alpha in the wrong order. Okay, let's check it. It does look kind of cool, like a little helix from biology. All right, so let's do pi over 6 minus x.
Oh.
Sorry, man. 20 years of experience. But hey, here's the thing. All three of these are the same. And they're easy enough to check that we should be expected to be able to do that on our own. Okay? Check it. Don't accept the fact that, hey, I think this is right. Prove it. Okay. Alright? I know. I want to go through a couple of problems from last week. Because those are some homework problems. I want to see if there were any questions from the homework that we assigned last week. And assign tonight's homework as well. So, any questions from last week's homework assignment?
Yeah.
Which was posted. And
You got one.
he's got one. Hold on, let me catch up to you. 9.2. Let's see, we did 4 through 9 and 42 through 46. Questions?
46.
46. All right.
I think I got it.
Oh, no. There we go. All right, we had a request for number 46 from the homework.
What's the homework?
Oh, for tonight?
For days like this.
Oh, I posted a new question, man.
Oh, crap.
The homework for today. Homework for today should be 10 through 19. And 25 to 32.
Is this like a different section?
32. Nope, it's all the same section.
So
10 through 19.
This is 9 too.
Yep, still 9-2. Like I said, I was going to try something different this time. You know, give you the entire homework assignment and then give you the pieces that you don't want in that section. And 25 to 32. All.
Yes.
Now, some of them say the graph. He's a graphing calculator. Okay. You already had the graphing chapter. Alright, this is the graph.
Can you tell me what the other day?
So do the flashing.
You just post the whole like.
And in the description, you can say which ones are which.
In the answer.
No. Alright. 46. Okay, number 46 says tangent of negative 15. So you tangent. So you gave me a hard problem.
So hold on.
I can see how it is.
I think I got it.
Okay.
Would it be tangent negative 45 plus 30,
That's one way.
and then that's all I put.
That is one way to do it.
And then to set it up with that v square root 3 over 3 since it's flat.
So you're going to use this formula. This is plus, right?
Yeah.
Okay, so I'm going to stop you right there. I think you're going to be on the right track if you do it that way. Anybody else in 46? Did anybody see a different way to get to negative 15?
I didn't do the homework, so I don't know what kind of.
So yeah, there's another option.
Or is this 9.1 or 2? Sure.
9.2.
It's not 9.1.
No, it's not.
That's another way. Notice we use a different version of the formulas because it would be subtraction rather than addition.
Oh, me.
I'm gonna do it your way unless you say otherwise.
No.
Want to do it this way?
Yeah.
You think Madeline's really smart?
No.
Mr. Douglas, are you sure you can't put 9.2 in there?
Yeah.
Not sure.
There's videos.
It's in there, Douglas. I just had it on here.
I was just asking. Exactly.
did that
Ah, there it is.
Where?
Today's video and homework.
Then it says Stoic 49 and 40, 46 all.
Yep.
And that's all I missed, all the homework I missed.
Sorry about that here. All right, 46. So you requested a different approach. We're going to do 30 minus 45. Let's do it. So we do. So as a reminder, the tangent ones are the most pain because you have to simplify as far as you can.
Are you
Yeah,
okay,
this
sir?
No, I'm dying. All right. Let's do it. We do tangent of alpha, so tangent of 30, minus tangent of beta, so tangent of 45, over 1 plus tangent alpha, tangent beta, so tangent 45. I'll be honest, when I did this problem, I did not choose those two.
Which one did you choose?
I did 45 minus 60.
Why?
You'll see why in a minute.
Alright, I'm doing that one then.
Okay, here we go. No. You said this is what you wanted to do. You even switched once already. I've been doing this a long time. I know how these work. I know it's going to be a pain.
How do I get 60 from that?
Because 45 minus 60 gives you negative 15.
Duh.
Remember my goal, Garrett? My goal. I want two numbers that get me back to the original value. By either addition or subtraction.
See, I did.
Oh yeah, you were here. My bad. Okay, I'm sorry.
Yeah.
My bad.
Okay, so
I forgot.
I'm going to keep
My
going
bad.
with what I was recommended by Madeline. Here we go. Tangent of 30, that is square root 3 over 3. Minus tangent of 45, 1. All over, 1 plus square root 3 over 3, and 1. So we end up with this rather annoying fraction. Square root 3 over 3 minus 1 over 1 plus square root 3 over 3. And now, to get to the solution, I have to employ a lot of algebra. I have to combine the top fraction into one big fraction, the bottom fraction into one big fraction, then use KFC to simplify each of those fractions. You're hearing the pain already. Yes.
Let's just try yours.
My way gets rid of at least two of those steps.
Okay, let's do it then.
Okay, can I show you a comparison?
Sure.
Okay.
Let's just finish it this way.
Oh yeah, it's just
Okay, I want to show you just the side by side. So my way would have been to take tangent of 45 minus tangent of 60. This only comes from experience, guys. The more these problems you do, the more you'll be like, I don't want to do the painful way anymore. Can I find a better way? Here's the thing. If I simplify the one we have right now, I have to get them to have the same denominator and use KFC to fix it, right? So to do that, I'd make this 3 over 3. I'd make this one 3 over 3. So they all have the same denominator. The top becomes square root 3
What are you solving
minus
the first
3
one now?
over 3.
Or is this your version?
Oh, this is top one.
So it becomes this. You can either use KFC, or I prefer to do the old-fashioned thing, which is just to cancel. I have a divide by 3 on top. I have a divide by 3 on bottom. This gives me square root of 3 minus 3 on top. 3 plus square root of 3 on bottom.
So that's the answer?
And then I still have to fix it.
Man.
I'm not allowed to run around with a radical down.
I thought you said you didn't care, Trig.
These ones, if you want to get the book answer, you have to. You have to keep going.
So that's not it.
Okay, the nice thing is, if I do this with the other version, I get a simpler version faster. So look at my version now. So this is Madeline plus Cole's path. They go to here, and then they just keep simplifying algebraically. Keep simplifying, keep simplifying, keep simplifying. Oh! Okay. Okay, my version. Why did I choose 45 minus 60? Because tangent of 45 is 1, and tangent of 60 does not have a fraction. This becomes 1 minus square root of 3 over 1 plus square root of 3. It turns out those two are the same. They're the exact same thing. But notice, I got there in one step. I got rid of the fractions and KFC all in one step by just picking smarter values at the beginning. Tangent has a lot of these where if you pick smart values, you get it faster. If you pick bad values, you get it slower. That does not mean you will not get there. It means it will take longer to get there. So again, this rewards those of you that will look at a problem and be like, I want to take a smarter path, so let me think a step ahead. What happens if I choose 30 and 45? Yeah, those two numbers do get to negative 15, but tangent of 30 is not nice. It's square root over 3, I get a fraction. And I know from working these tangent problems, fractions and fractions are nasty. Whereas 45 and 16 also give me negative 15. But one of them doesn't have a fraction. So it's nicer. Like I said, just an alternative way to do it. And again, both of them are going to work. So why choose this path? Well, that's because it's the first one you saw. Most likely, right?
Yep.
And that's okay. It really is. It really is. Okay? Just know that doesn't mean it's the best path. Okay? You ever be driving down to like Bella Vista or Kenosha? Or you get stuck in traffic?
Never
At
get
that
stopped.
light?
Never get stopped.
But what?
That light by the Dream Walmart?
No.
Yeah, they're going
That's
up
not
there.
the bad one. Led by Starbucks.
That one, yeah. So, well, let me use the one by Jake because most of you guys probably been there. You choose the wrong side, you're not going to get. And when you were pulling up, I'm sure it may have seemed like a shorter line,
But it takes a long.
but it might take longer. Well, 30 minus 45 is that tractor trailer line. It looks shorter because it's 30 minus 45, it gets me there quick. But long term, you know, if you stuck behind that piddly piddly tractor trailer going 15 to 45. Don't road rage this math problem, alright?
So is there any way so I get this, I get what you're doing here.
Huh?
I just gotta remember, so the problem would be like tangent of negative 15, right?
Yes.
And then you get two things that like,
Yes.
basically like factor rule, right?
Yeah, factoring is not the word. There's a special fancy word for it.
Well, it's like the same concept.
It's a
as, like,
substitution.
AC.
It's substitution.
Okay. So what else did I miss? Like what other type of problems did you learn?
We only did that with Wilson last week.
That's the one thing.
Yeah. So we did a lot of answering questions from 9-1.
It just came to class.
Alright. Other questions from last week's homework assignment for Friday. It was 4 through 9 and 42 to 46. Okay. You have 5 minutes remaining. I'm going to stop the video.